So what's the difference between a video with 500,000 views and one with 100 million? Well, maybe just a little bit of rhetorical know-how. Dear friends, welcome back to the show. I'm kind of excited about this one because we're talking about the topic that I did my dissertation research on. What that really means is that the trauma of actually doing the project has worn off enough that I'm ready to start talking a little bit about it. See, when I started, I really wanted to know why there was all kinds of science content out there and comparatively little humanities content, especially stuff about rhetoric. I mean, I love a good science video as much as the next person, and I remember watching all kinds of science content through college and earlier, but I also spent that time wishing that YouTube had stuff about the things that I was most interested in. When I started thinking about doing this research project, I heard a couple of common assumptions. The first was that it was easy to make science content because it was more visual and exciting, or in other words, you could film explosions and then show them to people. And the second was that things like English and the humanities were harder to make popular because they were more abstract and their theoretical nature meant that the common folk just couldn't understand or appreciate it. Unsurprisingly, I thought that was a ridiculous reason as much as it was a clown circus of self-congratulation. In other words, I was pretty sure that science content wasn't popular just because it was about science instead of rhetoric. But, as any rhetorician would, I hypothesized that science content was popular because the people who popularized science were doing something rhetorical that the rest of us non-science types weren't doing to attract and build audiences. So from there, I set off on a year-long project, watching all kinds of YouTube videos about science and reading all kinds of rhetorical theory in order to understand what those science popularizers, or the people who are communicating science knowledge to non-scientists, were doing that made people so excited about science. What, in other words, were the rhetorical strategies behind effective popularization? And today, I thought I'd show you something I noticed in the development of the channel Veritasium and share some rhetorical theory that I think explains at least some of the channel's massive popularity. Hey now, this is good stuff. Besides, I've even got a job for you to do. No, come on, this'll be fun. Like me, Derek from Veritasium seems to have started making videos during graduate school, and then he wrote his dissertation about educational videos. Unlike me, though, he's a scientist who makes science videos, and nearly all of his videos have more views by themselves than this whole channel has combined. But hey, it's about quality, not quantity, right? Well, sure, but does he have some kind of alchemical entity on his shelf who doubles up as a projector? Anyway, let's get to the point. As I started reviewing the channel, I noticed something about the earlier videos Derek had put out. Actually, let's take a look at some selections from a few of them and see what you notice. Okay, so we'll begin with a video from 13 years ago, not even a full year after Veritasium first stepped onto the YouTube stage. It gives us a little science history and explains how experiments with cathode ray tubes led to our modern understanding of atoms. Here's a selection from it.
Over the next 40 years, they basically came to the conclusion, well, it was J.J. Thomson in 1897 who came up with the idea that there is a stream of very small charged particles, negatively charged. They're smaller than an atom. So the smallest atom, hydrogen atom, they're about 1,000th of the size of that. And it doesn't matter what material the metal is, it's always the same particle. So this particle appears to be in everything. This electron, as it was known, is what's carrying the electricity.
So Thomson came to the conclusion that all atoms have this particle as one of their constituents.
That's right.
So what do you see? I'm seeing something that aligns pretty closely with what I think most people think of when they think of science communication. We have a graduate student talking to a professor, clearly in a lecture hall, explaining particle physics and science history in simple, accessible terms. Right? I mean, this is the job. If you're a scientist with a lot of complex scientific knowledge and you want to share it with people who don't have all your sophisticated scientific training, you have to simplify things and make them easier to understand or process. So what we get is a demonstration of the cathode ray tube and an explanation in simple terms of how it changed the way we think about atoms, all in an attention span appropriate 3 minutes. job done. But of course, like I mentioned, our Veritastic friend Derek wrote a dissertation on science education videos. So, like anyone who's written a dissertation on anything, he seems to have had some strong convictions about what his videos needed to do in order to be effective. As a result, we got a series of videos where he hit the streets and asked everyday non-scientists some simple physics questions. Here's some selections from one about forces, acceleration, and the spinning Earth.
It's rotation, velocity, speed. There's some word you're looking for.
There is a word I'm looking for.
Rotating, spinning,
You're so close.
moving.
You put a force on an object, a net force, an unbalanced force, and it... Come on.
Goes.
Go, the least scientific word ever. It goes. You studied physics, right?
Yeah, which means I'm probably looking a little bit like a moron here,
No,
but
you're not
that's
looking
okay.
like a moron at all.
And here are some clips from another about thermal conductivity.
Here is an aluminium block and
Ooh, nice and cold.
a plastic block.
Yeah.
How do their temperatures compare?
Completely different. Completely different.
Aluminium's much colder.
Yeah.
Yeah?
Yeah, this actually feels colder.
Let's take this to the next level. I'm gonna put an ice cube on both plates. What are we gonna see?
Well, I'm guessing it would stay solid on this one and melt on this one.
So it's going to melt on the plastic but stay solid on the aluminium.
Yes, but maybe I'm wrong.
That one will melt more quickly than on the aluminium block.
You would think so. I think they're colder.
Yeah, because it's cold.
Let's
And
actually...
I think they're going to go the same.
All right, so we put an ice cube on each of those blocks.
Wow.
What are you seeing?
Well, it is melting a lot quicker on the aluminium.
Now, dissertations are not written to be read, and I haven't read all of Derek's dissertation, but one of the key takeaways is that people learn from science videos better when you present a misconception and correct it than if you just teach the facts alone. That is, people's understanding of science is better when you deliberately and explicitly challenge underlying misunderstandings. So the approach here is to collect examples of real people's real misconceptions and then correct them so that the viewers of the videos learn the physics better. But respectfully, here's where we see a great argument for the value of humanist approaches to knowledge. Because what happens when you record a bunch of regular people saying foolish things and then broadcast it to a bunch of regular people who might have said the same foolish things, but were just lucky enough not to have been recorded that day? Well, it's not very scientific to say, but they're probably going to feel bad. And that's not just me saying that. In the video, Why Do You Make People Look Stupid?, he directly addresses comments from viewers that call him various shades of pretentious, arrogant, and high on himself. And of course, in these videos, the goal is not to set himself up as the big smart science man, but to execute on something that he had discovered empirically. Show people what they get wrong in order to help them learn how to get it right. But enough of his viewers reacted poorly to that approach enough times that he ended up feeling the need to address it. And I get it, nobody likes feeling dumb, and YouTube commenters are sometimes very keen to try to one-up the people with PhDs who make content in their specialties. But these videos, while they do illustrate well-conceived research, also open the door to a common misconception about popularizing science. That it's not just simplifying things, but dumbing them down. This is the idea that the intellectual work of researchers and scholars is simply beyond the reach of real people, and that to communicate specialized knowledge to the public is, fundamentally, to water it down or to distort it somehow by simplifying it. It's a view that keeps specialized knowledge in specialized contexts, and it prevents scholars from sharing their work beyond peer-reviewed journals and conferences. It's also a view that I encountered again and again as a student. In college, I grew weary of all the times I heard professors mention something interesting and then say it wasn't something they discussed with undergraduates, as if learning one theory of grammar or another would short-circuit our brains. And I've already mentioned the attitude I encountered among the English department when I was starting my dissertation, that the work of English scholars was too theoretical for the public to grasp. When I asked around if anyone knew of rhetoricians who were engaged in real public-facing work, the best answer I got was an academic who sometimes tweeted things at other academics. I mean, it is public-facing, but we all know it's not that useful. But I'm getting distracted. The point is this. The traditional conception of popularization is that science communicators have the job of simplifying scientific knowledge for little civilian brains while minimizing the distortion that is an unavoidable consequence of that simplification. Dumb it down as much as you can, but damage it as little as possible. And to be clear, I'm not saying that Veritasium's early days were an exercise in dumbing things down. but that they do seem to be clearly motivated by an effort to transmit scientific knowledge as accurately as possible and in as simple of terms as possible. And it would be crazy to call these early videos failures. You know, they have reached audiences far larger than this show's greatest successes, but compared to where Veritasium went from here, it's clear that they don't represent an optimal popularizing strategy. Teaching someone physics is different from inspiring them to become interested in physics, and just simplifying physics isn't going to do the trick. Now, we've all been together long enough that you might know that when you take information created by, for, and among scientists and attempt to share it with the general public, you're not just simplifying a message, you're addressing a new audience, and that means that you're stepping into a whole new rhetorical situation, which will require an entirely different set of rhetorical strategies. That is, this isn't so much a problem of science as it is a problem of rhetoric, and for answers we can and should then turn to rhetorical scholarship. For example, as Jeannie Fonestock puts it in a 2004 study of Popular Science articles, from a rhetorical perspective, the problem in addressing scientific research to different audiences is not merely one of transferring information with more or less accuracy. At issue is how a scientific argument can be adapted for different audiences with different needs, interests, and background knowledge, and yet remain recognizably the same argument. She then writes, the versions for wider audiences sampled in this study demonstrate that it is possible to epitomize a scientific argument in a non-trivial way that preserves the core of the research design. Therefore, assuming that an exigence can be found for addressing a non-specialist audience, any failure in the presentation of the core argument may represent more of a failure of will or of art than the inherent inaccessibility of the material. In other words, it is possible to communicate specialized knowledge to a non-specialist audience without dumbing it down, but it involves presenting that knowledge in a radically different way, a way that the audience will care about. And failing to popularize your knowledge isn't the result of your discipline being too theoretical or your audience just being a bunch of dum-dums. It's the result of your own rhetorical shortcomings. Luckily, though, that's a really fixable problem. Now, it might feel obvious what the goal of science popularization is if you just look at the name. It's not called science simplification, after all. But the goal isn't just to simplify, it's to make science popular, to give it some kind of public appeal. And if we're just using viewership numbers as a way to measure a science video's popularity, it's clear that brief demonstrations in classrooms and man-on-the-street interviews weren't Veritasium's most winningest strategies. So let's take a look at a couple of the most popular videos on the channel and talk about what they do differently from the videos we've already seen. And to do that, we might as well begin with the most viewed video on the channel. Here's the introduction.
These are shade balls. They're being dumped into this water reservoir in Los Angeles. And contrary to what you may have heard, their main purpose is not to reduce evaporation. So what are they really for? To find out, I'm visiting the largest collection of these balls anywhere on Earth at LA Reservoir. $96 million shade balls.
That's correct.
96 million. It's very rare for you to see 96 million of anything. Yeah. Looking at this, I had so many questions. Like, why are they black? Are they safe to have in drinking water? How much do they cost? Do they actually reduce evaporation? And what is their real purpose?
So, charmingly, we do get a correction of a misconception right out of the gate. These balls aren't evaporation reducers. But then, we get something very different from what we saw in the earlier videos. Our protagonist comments on how amazing and unusual it is to see 96 million of anything, and then raises questions about the practical usefulness of the shade balls. We see similar strategies in the introductions to other popular videos too, like this one about aerogels.
This is aerogel, the world's lightest, that is least dense solid. This piece has a mass of just 1.22 grams. That is only a few times the mass of the same volume of air, which kind of makes sense because it is 99.8% air. In fact, some aerogels are so light that if you removed all the air from them, they would be less dense than air. I have long been fascinated by aerogel, so I actually flew out to Aerogel Technologies in Boston to find out, why was aerogel invented? How is it made? Why is it such a good thermal insulator? And what is it used for?
Again, here we're treated to the expectation-defying properties of aerogel. It has nearly the same mass as air, is almost entirely air, but can also protect someone's hand from an open flame and apparently does things on Mars too. So we bask in the spectacle of this unusual material and then start to consider its applications. Of course, to see more, you'll have to watch the video yourself. I've put links to all these videos in the description. And for just one more, we see the opening to this video that discusses the history of the kilogram as a unit of measure.
Can I hold it?
Only if you promise to be really, really careful.
I promise I will be so incredibly careful. I will be incredibly careful with it.
Okay.
I promise.
All right. So it's slippery. Be careful.
All right. Are you ready? I'm about to touch a 1 kilogram sphere of silicon-28 atoms. There are about 2.15 times 10 to the 25 of them. Oh. It feels absolutely incredible. Wow, that is amazing. Besides its creators, I am one of only a handful of people ever to hold this sphere. The raw material used to make it was worth 1 million euros, but now that it has been so precisely sculpted, how much is that worth?
It's priceless. This you are looking at now is the roundest object in the world.
How can you say for sure that it's the roundest object? I mean, the Earth is pretty round, isn't it?
If this was the Earth,
If this were the Earth, then the highest mountain and the lowest valley would be...
about 14 meters apart.
That is shocking.
We're not asking people on the street to define the kilogram. We're not showing people a classroom lecture on SI units. Instead, we're witnessing a spectacularly expensive, precision-crafted object and all the anticipation, anxiety, and amazement of a human being who gets to hold it. But why? If the goal is to teach people something about water chemistry or aerogels or the history of defining units of measure, why not just explain those things in simple terms? Well, because just explaining things does not make them popular. But why do these videos with such different opening strategies from the previous set have view counts orders of magnitude higher than those earlier videos? Of course, I can't say for sure what happened behind the scenes, but they are all clearly demonstrating a much more rhetorically savvy approach. An approach that Fahnestock described in a 1986 paper called Accommodating Science, the Rhetorical Life of Scientific Facts, like this. With a significant change in rhetorical situation comes a change in genre. And instead of simply reporting facts for a different audience, scientific accommodations are overwhelmingly epideictic. Their main purpose is to celebrate rather than validate. Aha! Here's some rhetorical jargon that we're familiar with. If you remember our long ago discussion of Aristotle's rhetoric, Aristotle defines 3 main genres of rhetorical discourse, one of which is epideictic, commonly defined as the rhetoric of praise or blame. It describes the kind of speech you give on a solemn occasion, eulogizing the dead, condemning foreign invaders, praising the hardiness of the laborer. Epideictic rhetoric is meant to persuade an audience that something or someone is either awesome or terrible. So Fahnestock is arguing that science popularizers aren't just in the business of presenting simplified messages, they're creating entirely different kinds of messages. Where scientists writing to each other are engaged in the task of creating and validating scientific knowledge, science popularizers writing for public audiences are engaged in the task of putting scientific knowledge on display in order to show us why that knowledge is awesome. And Fahnestock further points out that science accommodators have, at bottom, only 2 basic appeals to make in their epideictic arguments. For convenience, I will call these the wonder and the application appeals. So effective popularization generally will show why science is wonderful or why it's useful. And we can see Derek doing both of those things in the first minutes of each of these videos. The sheer scale of 96 million shade balls is astounding. Asking whether it's safe to use them with drinking water leads us to a discussion of what makes the science of those balls useful. The phenomenal properties of aerogel fill us with a sense of fascinated wonder, and demonstrations of its insulating capacity and association with the Mars rover show us its application. And, of course, we're absorbed in the spectacle, the awe of being around the world's roundest object. We don't get to see much application early on, but the video does go on to tell us why it's useful to think about the kilogram in different ways. And these strategies are largely absent from the earlier videos we looked at. We learn about cathode ray tubes and atoms, but it's not particularly awe-inspiring to watch Derek quietly nod while a professor explains the historical experiment. And we learn about acceleration and the rotation of the Earth, but not really why that's useful to know. We see some people guess incorrectly which ice cube will melt faster, but who cares? As much as those early videos were appropriately simplified and designed to ensure proper learning, they hadn't made the crucial shift to epideictic rhetoric that is at the heart of popularizing science. The most popular videos on the channel, sure, they benefited from being published on an established channel, having higher production values and including a wider cast of characters, but they're also doing fundamentally different rhetorical work. They open not with validation of knowledge, but with displays of wonder, with epideictic appeals that make the science, well, appealing to a broader audience. They do, in other words, the job that Phonostock describes like this. The true accommodation involves finding the points of interest in the topic that will appeal to readers who are not specialists in any science, by showing viewers not why scientists value aerogels or kilograms, but why regular old people like you and me can and should be excited about those things. And that's not to say that popularizing is just a game of turning science into a spectacle. It's not about cheapening intellectual pursuits and turning them into sensationalized content. These videos also give us real discussions of water chemistry and treatment, aerogel research, and the importance of defining units of measure in terms of mathematical constants instead of physical references. As a popularizer in the fullest sense, Derek isn't dumbing down the science. He's recognizing that real people aren't going to be interested in science for the same reason as scientists, and that his job is to give people a way in, or some reason to be interested. More recently, I think there are some observable differences in the Veritasium strategy, especially in the way Derek enacts his authority as a popularizer, but the fundamental epideictic gesture is still there from the start. Take this video about the uncanny ubiquity of the number 37 that opens up with the wonder and astonishment that Derek and his producer Emily express when they return to the streets. Not to ask people to answer physics questions, but to pick a random number, which, strangely, regularly ends up being 37.
Let me show you something unbelievable. Name a random number between 1 and 100.
61.
Okay, that's pretty random.
Let's name a random number from 1 to 100. Random.
43.
43. Thank you so much.
56.
7.
I want the most random number between 1 and 100, like totally random.
11.
37.
79.
79. Thank you so much.
91. 7.
3.
37.
37? Why 37?
Oh, no, it's just the first number that came from 1. 44. 27.
37. 72.
4. 13.
7. 37.
Really?
59. Merci.
13.
7.
37. 37.
73.
37. 35. 37.
37. No way.
43.
2.
37.
I knew you were gonna do it. You just 37 and walked away.
Between 1 and 100.
No thanks.
Okay.
37.
Oh, perfect. Thank you so much.
83. 37.
37.
87.
55. 37. 37. Oh, can I shake your hand?
I love the thought you're putting into this.
37?
No, you are kidding me! Are you real?
Yeah, what?
Did we ask you this already?
No.
Random number between 1 to 100.
37.
37. Oh my gosh, yes.
Name a random number between 1 and 100.
37.
Are you kidding me? Why?
So not only are we not seeing regular people like you and me set up as if they were the butt of a joke, but we see Derek and Emily literally celebrate each occurrence of the number 37. You just gotta love the epideixis. But the video goes on to describe a large random number survey that they conducted and to discuss the various surprising ways, both wondrous and useful, that the number 37 shows up. And of course, the video spares us none of the mathematical nitty-gritty. So we can see how, from early days that were perhaps too closely rooted in his classroom and research experience, Derek from Veritasium stepped into the role of the popularizer and found a way to make science wildly popular by shifting genres and making not just educational content, but epideictic content. Content that shows people not just what they should know about science, but why they should be and remain excited about it. See, what'd I tell you? I said we were going to have fun, and we had a lot of fun. No, we did have fun. Well, fine, I had fun, and you played an important role. Anyway, though, we may not be science popularizers, but the work that popularizers do shows us some interesting and useful rhetorical principles that can be useful to us no matter what we're doing. And the first is that you absolutely must begin by thinking about what would get your audience to care about what you have to say. It really isn't and can't be just about the facts, and that's not some cynical nonsense about how people don't care about truth anymore. It's just a recognition of human nature. We tend not to spend much energy on things we don't care about. So if you want your audience to spend energy on your thing, you've got to give them a reason to care about it. And wonder and application are two great ways to get people to care. Show them why your thing is awesome and they'll be invested. Show them why it's useful, and they'll get right on board. We've also seen how ancient rhetorical theory, like Aristotle's idea of epideictic rhetoric, can help us to understand something as modern as how to make better science content on YouTube. And this is what I love about rhetoric. It can touch every discipline, whether it's poetry or particle physics, and it gives us tools to understand human communication in all its forms. Modern rhetoricians have done an embarrassingly bad job of communicating what makes our work cool to a wider audience. But it's encouraging to see scientists making such good use of rhetorical tools to share what they love. Surely, if the scientists have figured out the public rhetoric game, the rhetoricians aren't a lost cause. But anyway, I think that'll do it for today. Thank you, as always, for joining me on this jaunt through the rhetoric of science. I've got plenty more to say about the topic, so we can all look forward to that. But I'd also love to know what you'd like to see more of. Do you have questions about writing that I can answer? Are there other fields or content that you'd like to see get the rhetorical analysis treatment? It's summer now, so I've got a little extra time on my hands. I do have some exciting things planned, but I also want to be responsive to what all of you are interested in. Let me know in the comments, on the Discord, or by telepathy, and provided I see or receive your ideas, I'll put them on the list. So thanks again, and have a great week. We'll see you real soon.